Hi, hello to everyone. This is Dr. Satheesh Kumar, working as the Associate Professor in the Department of Information Technology, Institute of Aeronautical Engineering, Hyderabad. So, in this session, we are going to see about a production system in state-space search. Okay, so what is a production system? So, how that new platform, that is new structures, going to be provided for the AI system for solving some particular or certain problems using some various searching techniques. In the previous video, we have seen various searching techniques. So, what are the various searching techniques used by the AI message? So, in this lecture, just we are going to see what is the production system exactly used in the searching technique. So, production system, various production system characteristics, the problem characteristics, various problems or characteristics we are going to be keeping in mind few things just before we are going to solve some problem using the searching. So, first we will see what is the production system. Okay, so the production system is nothing but it provides some structure or some specific platform to the AI machine to search a problem or some process, something to search start a search process, right? So it will consist of the various definition. Okay, what is the production system? It will give the various definition. The first one is set of rules. Okay, so generally the set of rules means just if you are going to do something or the machine or some technical words if you are going to do, we have to follow some rules. Okay, based on some protocols. Okay, just we have to follow some certain protocols to do the some particular task. Okay, here in the production system in AI, that both the left side and right side values are going to be represented. That is right hand side or left hand side. With the left hand side, which one? What is going to be taking the problem settings? Okay, in the right hand side, it will give you some solution for the particular problem. So, for example, A equal to B. Right here, the solution problem of the searching is A. Okay, the solution of the particular problem is B. Okay, so the B is going to be represented as A. Okay, so the left hand side is a problem state, and the right hand side is here the solution state of the particular problem state. Okay, either like that will be give some rules. Okay, if it is so, just we have rules. So for negation A and B. Okay, if it is so, that our final output, the final solution going to be represented as the problem statement. Okay, so that is some set of rules in production system. The second one is the term right hand representation. Okay, right hand represent the set of operation unequal to the left hand side. Okay, which I said in the previous one, that A equal to B. So what is the left hand side, what is the right hand side going to be represented in the production system? That is the second one. Okay, the third one is knowledge base. The knowledge base or database. Just if you're saying that a database, what is a database? We have to store something. What are the solution? What are the problem statement that going to be stored in the database? Okay, so that is the simply I call here knowledge base. Okay, knowledge base or a database, right? So the last one is a rule applier. Okay, we have a various rule, we have a various protocol that we have to follow. Okay, while you are solving one problem using the searching concepts in the production system, just we have to apply some rules. Okay, various rules, right? So that is the rule applier in production system. The next one is various types of the production system is monotonic production system and non-monotonic production system, partially commutative production system, non-partially commutative production system, and the last one is a commutative production system. Just we will see what is the all the types one by one. And the first one is a monotonic production system. Here the application rules. Okay, so we have different applications. Just we are going to apply one rule will never prevent the other rules. Okay, so if it is so, with the monotonic production system, the searching concepts, if you are applying some rules on the particular application, okay, then we can give some other application also. Okay, so if you are giving one rule, then it will support other rules also. Okay, it will not prevent the other rules. Okay, there is a monotonic production system. The second one is a monotonic production system. It is so, the rule, if you are fixing one rule for particular application in the production system, it should be followed. Okay, the other rule will not support it, will not prevent the current rule. Okay, that's the meaning here. The application of a rule will prevent the other rules. Okay, so it will not allow to go for other rules. If you are giving one rules, you have to follow until otherwise completion of problem statement. Okay, so that is the non-monotonic production system. The next one is the partially commutative production system. Okay, the partially commutative production system is nothing but the transfer the application rule from one state to another state. Okay, just if we have A, comma B. Okay, so now we are going to apply one rule for the state A, and that rule is going to be transformed to the state B. Okay, the simply they will tell the state X of state Y. Okay, this rule of X will be transferred to the state to Y. Okay, so this is the meaning of partially commutative production system. The next one is non-partially commutative production system. Here the application rule transform is not applicable. It is not possible. Okay, so if you are applying to the state X, one rule means that rule will not use to the, or it will not transfer to the state Y. Okay, so that is a non-partially commutative production system. The second is a commutative production system. So what is the commutative production system? What is the monotonic production system? It will adjust the other rules also. Okay, if you are following one rules, then we can give the another rules the same problem or same searching concepts. It will accept it. Okay, that is a monotonic. Then what is partially commutative rule? The rules are transferred to one state to another state. So what is the commutative production system? The combination of, the important is the combination of monotonic production system and partially commutative production system. So this is the various types of production system if you are going for searching techniques in artificial intelligence. Okay, for solving certain set of problems. So these are some specific rules of how to are going to give some specific structure to the searching process, right? So clear? The next one is what is the production system characteristics. It's nothing but if you are saying the production system characteristics or application. Okay, so what are the production system application or what are the production system, the characteristics, both is as same. Okay, the both is same meaning. Okay, so here we having a different production system, right? So monotonic, non-monotonic, partially commutative and non-partially commutative. So 1, 2, 3, 4. Total of 4 applications of a production system is there. So if you are going to take a partially commutative and monotonic the application, okay, how it will be used to provide the theorem proving. Okay, so it provide the theorem proving. If I having some problem statement, just if you see some searching concepts in the for problem solving, okay, it will provide some algorithms. Okay, it will provide some programmed algorithm to solve some particular problems. Okay, so that is the theorem proving. It will make some theorem and it will prove and it will reach some goal, or it will provide some appropriate solution or actual solution along with this partially commutative and monotonic. Okay, next one is same the partially commutative and non-monotonic. Okay, so if it is so, the robotic navigation it will be used. Okay, so this concept it will be used for the robot navigation. Okay, just for weather predictions or some signals or some image prediction, for that they will use the both application, both the partially commutative and non-monotonic production system they will use. Okay, the next one is non-partially commutative and monotonic. If you are using the both application, not partially commutative and monotonic, means it will use some chemical synthesis. Okay, just some chemical reaction. Just if you are making some chemicals, if you are making some on the chemicals, they will use this combination of applications. Okay, what is the non-partially commutative and monotonic? The next one is non-partially commutative and non-monotonic. Okay, some bridge. Okay, just for the computer network or somewhere, just we are going to connect between the several devices, several communication devices. We will use some concept of the bridges, right? That will be used in the applications of partially not partially commutative and non monotonic. Okay, so this is some specific application of a production system or some set of characteristics of a production system. Okay, the next one is the problem characteristics. So what are the problem characteristics are available, or what are the different categories are available in a production system to such a process in to solve some particular problem means, okay, to choose appropriate method. Okay, from this set of categories or set of characteristics, this we are going to choose some appropriate method to particular problem. First, we need to categorize the problem based on the following categories. Okay, the following characteristics or categories. So the first one is a problem is decomposable, okay, into small sub problems. Okay, so if you are having one problem statement, okay, for betterment of the solving the particular problem, just we are going to divide into in a number of sub programs, a number of pieces, right? So that is the first problem. If it is so, it will easy to solve a problem, right? So that is the first statement of the characteristics in searching processes. This problem is decomposable. Okay, so the second one is can solution step to be ignored or undone. Okay, so ignore or undone is a separate words, right? So if you are solving some particular problem, if you are following some particular steps, if you are following some protocols, okay, it should be or it is ignored. Okay, so some certain steps it is ignored, or some particular problem C is or some particular states are undone. Okay, that way just we are going to take a characteristics. The third one is in the universe of the problem is predictable. Okay, just some if you are having some solutions or if you are having some knowledge about the problem solving, it should be a predictable or as a universes. Okay, so the fourth one is a good solution to the problem is absolute or a relative. Okay, so if the system, okay, if the system means AI system will produce some appropriate solution or actual solution, it should be acceptable. Okay, it will be considered for the solution for the particular problem statement or not. Okay, so that is the fourth category. Okay, so what is the fifth category? Is a solution to the problem, a state or a path. Okay, that I will explain while we are seeing that fifth category. Okay, so what is the exact problem state or exactly what is a problem path in these categories. Okay, so what is the sixth one? What is the role of knowledge is in solving a problem using artificial intelligence? Okay, just if we have artificial intelligence to solve some set of problems, so what kind of knowledge they are going to use to solve some particular problems? Okay, so what specific steps or what specific states they are going to be considered, or what kind of knowledge they are going to follow to solve some particular problem using this AI machines or AI devices. So that is the sixth category. So what is the last one? Does the task of solving a problem require human interaction? Okay, so if you are giving some task to the artificial intelligence machines, so okay, so without human interaction, it would be solved, right? If it is so, that is a good machine. Okay, if some of the tasks without a human interaction, the machine could not complete. Also, whether the solves a particular problem by the artificial intelligence machines with the help of the human interaction or not, that will be categorized in the seventh one. So these are some set of characteristics or categories of production system for searching process. So just in the next we will see one by one. Okay, so here is the problem decomposable into small sub problems which are easily to solve, right? So I just already said, if you are having some problem statement, it should be divided by into some sub programs to solve, okay, to reach the goal, right? So for example, just we having one expressions, okay, that should be divided into a number of sub programs. Then again you have to solve each and every sub programs independently. Then again we have to reach some solution. That solution going to be merged. Okay, finally we will get some solution. So that solution will be considered for the final solution for the particular problem statement. Like this, we will go for the problem solving. Okay, for example, just I want to say, tell means, okay, merge chart. Everyone know familiar about the merge chart in the data structure or DOS subsets, right? If you are having the n number of elements, for example, 1, 2, 3, 4, 5. Okay, 3, 2, 4, 5, 6, 1. So just we have here six elements, totally 6 elements in the short. Okay, just I'm using here a merge short concept. Okay, just first of all, just we are going to divide it into 2. That is a number of elements divided by 2. Just we are going to use the divide concept. Okay, now here 3, 2, 4. Here 5, 6, 1. Okay, again just I am going to use divide the this one. Okay, here 3, 2, here 4, here 5, 6, here 1. Then just I am going to use some technique to short this one. Okay, now I am just going to use the descending order, that is 2, 3, then 4. Here it's already a correct shorted method only. Then no 1. Yes, right. Then now just I am going to just I'm going to merge. Again I'm going to merge the this divided concepts. Okay. So while we are merging here 2, 3, 4. This one, then 5, 6, 1. Then if I am going to merge again, I will merge this one 1, 2, 3, 4, 5, 6. So like this is a final goal state. There is an initial state. Okay, so I'm using the merge sort concept, so using the divided method. Just I'm going to solve the this problem with the sub programs. Like this, just I'm going to use to solve some particular problems using that problem decomposable concepts. It's clear, right? Now, second one is, can solution steps be ignored or undone? Okay, so here just already we said that if you are having some, for example, just 8 Brussels problem. 8 Brussels problem, just I am going to like this. Okay, just I'm going to use like this. Here, just I'm using the starting this 8 Brussels problem. Just I'm going to follow some certain rules. Okay, or some certain steps. Okay, so what are the steps just to solve this 8 Brussels problem? Just you have to move up or down, or have to move right or left. Okay, so in the certain problems, just we are going to ignore some steps to solve a particular problem. If it is so, it will provide some solutions or not. Like that, just we are going to see. Okay, so undone means if you are ignoring that particular steps, this problem is undone. Right? So if it is so that one, just we have to tell that it's an undone problem is. Okay, so see here, ignorable problems can be solved using a simple control structure that never backtracking. Okay, so if you are ignoring some particular steps also, it will reach the goal state. Okay, so if you are ignoring some up or down move or right or left to move, okay, it should reach some goal state. Right, so that is the first one. The second one is the recoverable portable can be solved using the backtracking. If you are using the some concepts, okay, and then problems, we are going to using some backtracking method to recoverable the particular steps. Okay, so irrecoverable problem can be solved by recoverable style method via the planning. So we are going to follow some planning, some particular methods or particular technical some particular searching concepts. We are going to solve here that some kind of problems that is irrecoverable. Okay, if you are having any you should not use any moves from here. So that one is second category. Okay, so third one is the universe of the problem is predictable. Okay, so it is having the two types. Okay, the certain outcome problems. Okay, the plan can be used to generate the sequence of operators. Okay, that is generated to lead the solution. Okay, if you are having some expressions, okay, here just we are going to use some addition or some scalar addition or some matrix addition or some subtraction, some multiplication. Okay, some special operators we are going to use to solve a particular the problem to reach the goal state. That is a certain outcome problems. You are going to use certain some outcomes, certain operators, some techniques. Okay, the second one is uncertain outcome problems. The sequence of generated operator can only the good probability of the leading up to the solutions. Okay, just if you are having some problems, okay, just you have to knowledge about the particular problems. Okay, then only it will be easy to give the some good solutions, right? Okay, so that's the concept of it is the universe of the problem is predicted. The next one is a good solution to the problem of absolute or relative. Okay, just it's the traveling space for problem. Just we will consider try to find some path to reach the destination. Okay, just we are going to find some shortest path, right? If the traveling space for problem is there, just we are going to reach the source to destination. Just we are going to use some shortest path to reach the destination. Okay, so if it is so, then the searching process, we are going to search any kind of a problem. We choose the any kind of a path to reach the destination. It will give some good solution. Okay, it will not consider as some exact solution or actual solutions, right? So this is the way that which way we are going to use the particular problem solving as a absolute or some relatives. The next one is a solution of the problem or state or path. Okay, so what is the state or path? Okay, just if you are having some 8 bustles problem, what is the initial state or what is the goal state? Okay, from the initial state, just we go for goal state. Okay, so which is type of state? Okay, we are going to follow to solve here some 8 bustles problem. That is a state. Okay, problem state. Okay, here the path means just we having some tree. Okay, so what is the path? Okay, A to B, B to E, B to D, D to F, like this. Just we are going to select some shortest path between this tree. Okay, to reach the root node to child node. Okay, so parent node to some child node. So what is the shortest path we are going to select to solve this problem? Okay, so that is the one way of a path. Okay, so which one the artificial intelligence machines are going to be instead of you going to be follow to solve a particular problem using the searching process. Okay, so is this a solution to the problem state or a path? Okay, the artificial intelligence machine should be realized it is a state of the problem or some path of the problem. Okay, so next one is what is the role of knowledge in solving a problem using the artificial intelligence? Okay, so in the artificial intelligence, just we have here so many techniques, so many problems, right? Like size of playing chess, buses, hill climbing. Okay, some water check problems, everything we have is a number of steps. Just we are going to follow the number of steps. Okay, here if you are having some playing chess means just we have to follow some fixed moves. Okay, either is left to move or right move, forward or backward, like that. Just we are going to make your steps. All right. So that is the playing check. Okay, if eight vessels problem. A Brussels problem also, just we are going to follow some certain steps, right? Just we have to move up, or we have to move down, or we have to move right, or we have to move left. Okay, so EPT, so just what kind of knowledge just we are going to apply to solve some particular problems, either it is a playing chess or 8% or edge problem or determining. Okay, so what type of knowledge we are going to use to solve a particular problem using in the artificial intelligence machines, that we have to be decided by the production system, right? The next one, the last one is the last categories of the production system is, does the task of solving a problem require human interaction? Okay, just if the artificial intelligence machines going to be start solving one particular problem is, okay, so what type of the interaction, what is the help of we need from the human? Okay, so sometimes it is useful to program computer solve a program. It way to majority of the people who would not be able to understand, right? If the machine gives you some solution, so either it is a good solution or actual solution, or solution, the human would not be the unknown people would not be understand. Okay, so at the time, just some human being have to be interacted with the particular the person, they have to explain. Okay, the machine would not, maybe. Okay, so that's the concept of the, does the task of the solving a problem requires the human interaction. This is a find the level of the interaction between the computer and the human user is problem in solution out. Okay, so if the artificial intelligence machine could not explain the particular what is the problem, what is the solution for the particular problem statement, the human should interaction with the artificial intelligence machines. They will explain to the third party what is the exact problem solution, what is the state, what is the path we are going to take to solve some particular problems. So this is some set of categories or characteristics of a protection system. The problem characteristics of using the searching concepts. In the next video, this we will see in the new concept. Have a happy day. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.